In a development that has shocked global defense analysts, the United States is on the cusp of revealing what many are calling the most revolutionary aircraft ever built. Often dubbed the Ghost Jet, this secretive fighter is shrouded in mystery and poised to redefine the future of warfare. Rumors suggest its debut might take place aboard the Navy's most advanced aircraft carrier, the USS Gerald R. With an array of futuristic features, this next-generation jet represents a massive leap in air dominance, pushing the limits of speed, stealth, and combat capability. Design that defies detection. At first glance, the jet's most eye-catching feature is its radical appearance. With no vertical stabilizers and a triangular tailless frame, its aerodynamic design screams stealth. Traditional aircraft shapes create radar reflections, but this sleek craft is built to vanish in plain sight. The aircraft's surface, known as smart skin, is embedded with thousands of microscopic sensors that continuously monitor environmental changes. These sensors can detect radar signals, adjust stealth coatings, and even relay battlefield data to allied aircraft in real time. This skin not only increases survivability, but turns the aircraft into a flying command hub. Beyond missiles, lasers, and AI-controlled swarms. One of the most exciting innovations is the onboard laser weaponry, capable of precision strikes that leave no room for enemy retaliation. Unlike missiles that can be jammed, intercepted, or require reloads, laser systems can fire continuously as long as power remains. In combat, the jet isn't alone. It commands a swarm of autonomous drones known as collaborative combat aircraft. These wingmen can carry additional weapons, serve as decoys, or even sacrifice themselves to protect the lead jet. While these drones operate semi-independently, they are fully integrated with the main aircraft's AI, allowing for lightning-fast responses and complex tactical maneuvers. Hypersonic speed. Perhaps the most jaw-dropping feature is its hypersonic speed, exceeding 6,000 miles per hour, Mach 8. At these velocities, the jet can strike anywhere on the globe within minutes, making it nearly impossible for adversaries to detect or intercept in time. Flying at hypersonic speeds presents formidable challenges. Friction with air molecules at such velocity generates extreme heat capable of melting conventional materials. Engineers have developed new composite materials, including heat-resistant carbon and ceramic blends that withstand temperatures over 2,000 degrees Celsius. Even more remarkable is its use of scramjet propulsion, which has no moving parts and uses the aircraft's own speed to compress incoming air. This enables combustion at hypersonic speeds, allowing for efficient, long-duration flight through both the upper atmosphere and the edge of space. A new framework for air superiority. The Ghost Jet is believed to be part of the Next Generation Air Dominance Program, a broad initiative to replace the aging F-18 Super Hornets and F-22 Raptors. But Next Generation Air Dominance isn't just about building one powerful aircraft. It's a networked system that includes piloted jets, autonomous drones, and advanced command infrastructure. The US Air Force has already confirmed that a Next Generation Air Dominance demonstrator had a successful test flight as early as 2020, surprising defense insiders who had no idea how advanced the project had become. The USS Gerald R. The USS Gerald R. Ford, America's most advanced aircraft carrier, is the perfect launch pad for these high-tech warplanes. Outfitted with electromagnetic aircraft launch systems, it can catapult aircraft faster and more efficiently than traditional steam-powered systems. Adding even more firepower is the Helios laser weapon system, a 150-kilowatt directed energy weapon capable of disabling incoming missiles, drones, or small boats with pinpoint accuracy. Unlike traditional missile systems, Helios can fire continuously as long as the ship's nuclear power plant supplies energy, making it a tireless defender in hostile environments. The race heats up. China and Russia respond. America's leap in aerial warfare is not going unnoticed. Both China and Russia have been investing heavily in stealth and hypersonic technologies. China's J-20 stealth fighter and Russia's PAKDP program are both aimed at closing the gap. These nations are expected to increase funding into space-capable fighters, advanced radar systems, and directed energy countermeasures to deal with the threat posed by US advancements. While America leads in implementation, its competitors are catching up in research. Satellite imagery has revealed secret Chinese and Russian testing grounds, signaling that the arms race in the skies is well underway. Airspace transition vehicles. At the heart of future combat lies a stunning concept: airspace transition vehicles. These aren't just jets, they're spacecraft. Spearheaded by Defense Advanced Research Projects Agency, these vehicles will take off like planes, ascend to low Earth orbit, and re-enter without relying on rockets or launch pads. The idea of a warplane that can transition between air and space opens up an entirely new realm of military strategy. Reconnaissance, missile interception, or direct attack from space becomes not just possible but routine. The implications are profound. With space-based fighters, nations can project power across continents and oceans in minutes, blurring the line between terrestrial and orbital warfare. Artificial intelligence, the true pilot of the future. At hypersonic speeds, pilots have milliseconds to make decisions, far faster than human cognition allows. To overcome this, AI-assisted systems are being embedded in every layer of next-gen fighters. These AI brains assist with navigation, threat detection, combat maneuvers, and even autonomous mission execution. What began as simple autopilot systems has now evolved into full-fledged AI co-commanders, capable of executing entire missions independently. Projects like Pentagon's Project Maven started by training AI to analyze drone footage, but have since expanded into real-time combat decision-making. These systems can track multiple moving targets even through smoke, fog, or electronic interference, giving them a distinct advantage over human pilots. Manufacturing reinvented. The way these aircraft are made has changed just as dramatically as their capabilities. Using advanced 3D printing, manufacturers now craft parts out of titanium and carbon composites in complex geometries impossible with traditional machining. Entire prototypes can be produced and tested in a matter of weeks, not years. AI-powered simulations test and refine designs virtually before a single bolt is ever assembled. This rapid iteration means militaries can constantly improve their fleets, releasing new versions with smarter features, rather than sticking to one model for decades. This strategy has led to a modular design philosophy. Weapons, sensors, and control systems can be swapped out quickly, making the aircraft adaptable and upgradable without major redesigns. It's estimated that this approach could reduce lifecycle costs by 30 to 40% compared to legacy systems. Smart skin and total situational awareness. Another breakthrough is the concept of smart skin. Instead of relying on external radars or fixed cameras, the aircraft's surface itself is a network of sensors, allowing full 360-degree awareness. This means no blind spots. Every angle of attack can be monitored and shared with other aircraft in real time. Combined with AI networking, entire squadrons can act as a single intelligent unit. Fighter jets can coordinate attacks, share data instantly, and react to threats as one synchronized force. Ethics and autonomy. Despite the excitement, the rise of AI-controlled warfare introduces serious ethical challenges. Current military doctrine insists that a human must remain in the loop for life and death decisions, but at Mach 8, human reaction times fall short. To address this, the Navy has formed ethical advisory boards to establish limits on autonomous combat, ensuring that systems act with restraint and follow international laws of engagement. Yet, programming ethics into code remains a daunting task. Advanced AI also requires immense computing power, which produces heat at levels that could cripple onboard systems. This has led to parallel research into quantum computing and futuristic cooling systems to maintain operational efficiency. A blurred line between fiction and reality. Gone are the sharp tails and angular designs of 20th century jets. These new aircraft, shaped by stealth and AI, look more like alien spacecraft than human inventions. Flow control systems have replaced stabilizers, and carbon nanotubes dissipate radar signals as harmless heat. Even infrared detection is being countered with exhaust cooling systems that reduce thermal signatures. Looking ahead, 7th generation concepts aim for space maneuverability, full autonomy, and near invisibility. With countries like Japan, the UK, and European coalitions launching their own future combat programs, we're entering the most competitive and transformative era in aviation history. Thanks for watching. If you found this deep dive into America's ghost jet and the future of aerial warfare as fascinating as we did, make sure to give this video a thumbs up and smash that subscribe button. Until then, fly safe, think smart, and aim higher.